Okay, people, everybody ready? Yay, Chris, we're ready.
Ready.
Okay, everybody's ready. We're going to hit module 10 here. Okay, network management, a lot of stuff in here, LLDP, CDP, configuration file management, password recovery, all that good stuff, TFTP. Okay, so get this on a roll. If it ever starts going. Should be able to use CDP to map a network topology, use link layer discovery protocol to map a network topology, implement network time protocol. Remember, it's UDP port 123 between an NTP client and NTP server. Explain how simple network management protocol operates. Remember, that's TCP, UDP, primarily UDP, 161 and 162. However, 161 goes both ways, UDP and TCP. Depends on how you're using it. Explain how SNMP, Simple Network Management Protocol, operates. Explain syslog operation. We already know you've used syslog. It's the log network messages to a device for archival purposes. Use commands to back up and restore an iOS config file. Implement protocols to manage the network. So, device discovery with CDP. CDP, Cisco Discovery Protocol, proprietary layer 2 protocol, media independent layer 2 protocol, used to gather information about Cisco devices and only Cisco devices. CDP only works between Cisco and Cisco. LLDP is the industry standard. It's an IEEE standard. I won't say industry standard, but it's an IEEE standard. Whereas CDP only runs between Cisco devices. Okay. Use protocol used to gather information about Cisco devices that share the same data link. That means wire. Okay. CDP is media and protocol independent, runs on all Cisco devices, such as routers, switches, and access servers. CDP is enabled by default, is what that means. LLDP is disabled. However, you do have the ability to run LLDP. The device sends periodic CDP advertisements to connected devices. The advertisements share information about the type of device discovered, name of the devices, number and types of interfaces, as well as a lot of other information. Native VLAN, VTP domain name, a whole bunch of stuff, iOS revision that you might not want disseminated to other devices on the network. To configure and verify it, look, for CDP, it's enabled by default. To verify the status of CDP and display information about CDP, you can enter the show CDP neighbor command. Show CDP neighbors, show CDP neighbor detail. To disable CDP on a specific interface, go to the interface like int G00 and type no CDP enable in interface config mode. CDP is still enabled on other interfaces on the device. However, no more advertisements are sent out that specific interface. To enable CDP on the specific interface again, enter the CDP enable command. To enable or disable CDP globally for all supported interfaces on the device, in global config, CDP run. Or no CDP run to shut down CDP on all interfaces on a Cisco device. Can be disabled for all the interfaces on the device with the no CDP run command in global config mode. Use the show CDP int command to display the interfaces that are CDP enabled on a device. Status of each interface is also displayed. With CDP enabled on the network, the show CDP neighbor command can be used to determine the network layout as shown in the output. Look, if you know how to draw and you know how to read CDP, you can actually map the network out device to device. Router connected to a switch, connected to an access server, connected to an ASA. Look, all of that can be mapped out, okay? The output shows there's another Cisco device, S1, connected to the G0/0/1 int on R1. Furthermore, S1 is connected through its F05 port. So here you see the device ID is switch 1. I see them from my gig 001 on R1. The hold time is 179 seconds. It's a switch, that's the S, running IGMP, Internet Group Management Protocol, multicast protocol. Anyway, management, multicast, same shit. It's a WS3560, and the port on the remote device, the switch itself, is F05. Okay. Show CDP neighbor detail. Note there's a lot of output omitted here, a lot of output, because when you type show CDP neighbor detail, it'll tell you everything, the device name, the IP address of the connected interface, or the device itself, exactly what it is. It's a 24 port 3560 TS capability, IGMP, connected via the local G001 interface on R1, F05 on the remote switch. Okay, the hold time 136 seconds. There would be a whole bunch of other information here, such as the operating system revision number, where it booted from, all kinds of stuff that you really don't want to propagate through the network. Okay. Anyway, there you go. Your first packet tracer of the day. Have fun. Toodles. See yous. Is everybody there? You still sleeping?
No, we here.
You gonna do the lab?
Yeah, sure.
You gonna make Papa proud and do the lab? I didn't get no response to that. It's Monday morning. Too early for that stupidity, huh?
Nah, I forgot. I was on mute. That was funny.
Work on the lab. There are a couple of labs in this module. All right. All of them are important because they're related to CDP, LLP, NTP, as well as operating system and file revision on the devices themselves. So these are important labs. You should do them all. Okay. In the meantime, knock out this one for the CDP. I'll give you about a half hour. How does that sound? That should be plenty of time to knock it out.
Perfect.
Good beans. A little bit. If you need me, holla. I'm sitting right here doing nothing.
All right.
I'm drinking my coffee, Pepsi. I know I said I like Coca-Cola in class. I know somebody's going to say something. But it's like when it's, the zombie apocalypse, you buy what you can buy, and they had Pepsi.
Pepsi it is. You went with the superior choice.
I prefer the Coke.
Pepsi is much better.
Now, this Pepsi got some fizz going, I'll tell you that, though.
Exactly.
It's got some fizz going, but I got some Coca-Cola in there, got some fizz, too.
That Pepsi fizz is different, though.
Oh, man. We're going to have to do another Coke Pepsi taste test if we ever get back.
And yeah, for real. We got to do it right. We got to do crisp, ice cold Pepsi and crisp, ice cold Coke.
There you go.
That way there's no debate. Once Pepsi wins.
Blind taste test. Knock out the lab. I'm here. If you need me, holla. Okay?
All right.
All right.
Everybody done? You done or you still working it?
About like 5 minutes.
Okay, 5 more minutes. All right, we ready?
Yep.
All right, rolling along here. Another lab coming up in a couple of minutes. LLDP, Link Layer Discovery Protocol. I believe it's 802.3 AD. Link Layer Discovery Protocol. Vendor neutral neighbor discovery protocol, similar to CDP. Works with network devices such as routers, switches, and wireless LAN access points. Protocol advertises identity and capabilities to other devices and receives the information from a physically connected layer 2 device. Okay, so remember, this is bound by the link. If you look at this picture, doesn't matter if it's CDP or LLDP, if there was something connected on the right side of that switch, the left side router would not be able to see it. The switch would see both because it has a link to each device. But you can only see devices that are directly attached. Nothing beyond the next hop device. Doesn't matter what it is, router, switch, doesn't matter. You can only see a physically connected. That means on that wire. LLDP may be enabled by default to enable LLDP globally on a Cisco networking device. Now, the reason why they say may be enabled by default is simply this. On non-Cisco equipment, LLDP is typically enabled. On Cisco, LLDP is disabled in favor of CDP, which is Cisco's layer 2 discovery protocol. Okay, link layer, I should say, which is more physical than layer 2. All right. So to enable LLDP globally on a Cisco network device, global config, type LLDP run, and that will enable it on all interfaces. Okay. To disable LLDP, use the no LLDP run in global config to disable it on all interfaces. Can be configured on specific interfaces. However, LLDP has to be configured separately to transmit and receive LLDP packets. To verify LLDP is enabled, use the show LLDP command in privilege exec. Do show LLDP in global configure any submode thereof. To enable it globally, LLDP run. To configure it on a specific interface, LLDP transmit, LLDP receive, show LLDP, and it will show you the status is active. Advertisements sent every 30 seconds, hold time is 120. Interface reinitialization delay is 2 seconds. So if an interface comes up after going down, LLDP will not enable itself for 2 seconds to allow the interface to stabilize. No sense sending stuff if the interface ain't stable. Show LLDP neighbors. It appears to give kind of the same information, okay, as, CDP, but trust me, on Cisco equipment, CDP information is far more comprehensive than LLDP will be. So on Cisco equipment, CDP, if it's Cisco to Cisco, if it's Cisco to another vendor like 3Com, Juniper, use LLDP on that interface, okay? Gives you the same kind of information, the device name, the local interface, hold time, what its capabilities are. Note, far less capabilities visible here than with CDP, okay? Let's go back a little bit and take a peek, because that's kind of important. Look at how much you can find out with Cisco. Look at what you can find out with LLDP. Okay? And the remote port identifier. Show LLDP neighbor detail. There is a lot of output omitted here. However, show CDP neighbor detail will give you far more information with Cisco equipment than you would get with LLDP. And there you can see all the basic information and all that good stuff, okay? Again, another packet tracer. You should do this. I'll give you another 20 minutes to do this. Since you already did the CDP, this one should be simple. Yes?
Yep.
I see 10:45, so figure 11:05, we're back at it. Okay? I'll give it till 11:05. This should be relatively simple to do. It's only a couple of commands and a little bit of verification, okay? And then we're on to NTP, Network Time Protocol, and there is a lab for that one. Network Time Protocol, you must know, because all networks are using NTP to correlate time. You cannot prosecute anybody that hacks into your network if your time is not fully synchronized on all your devices. If you're off by too much on any one device, a court will throw it out if you try to prosecute somebody for wiping you out. Okay? So work this LLDP, take 20 minutes. That's all you should really need. It's not too deep. Then we'll come back and we'll bust into the NTP side of it. Okay? Everybody good? Yay, Chris, you're the best.
Yep.
Good.
Good.
I smell bullshit. Ready to roll, people? Yay, Chris is back.
Yeah, maybe like a minute more or two.
A minute more? Okay, I'll give you 3 minutes more. So 7, I'll give you to like 10. Okay? 11:10. Then we'll get rolling.
Perfect.
All right, ready to roll on?
Yep.
Times on the skills assessment, 10 times. Retake them 10 times, okay?
Yep.
Right. Right. Network Time Protocol, NTP, UDP port 123. Remember that. It's important when you're configuring ACLs if you use an NTP in your network inbound on an interface. Outbound, router packets, router generated packets are not ever subject to outbound ACLs, except for distribute lists for advanced routing, which we do not do in CCNA, okay? So routing protocol packets, NTP, like that, if it's generated by the router, it is not subject to an outbound ACL. Is subject to an inbound ACL on the next top router, though. Software clock on a router or switch starts when the system boots. Primary source for time on the system. It's important to synchronize time across all devices on the network when time is not synchronized between devices. It's impossible to determine the order of events and the cause of an event. Typically, date and time settings on a router or switch can be set using one of two methods. You can manually configure date and time on each and every device. Now, how much sense does that make if you got like 75 devices? Absolutely none. Okay? And you can do that by setting the clock manually, typing on each device. Clock, space, set, space, and then the time in 24-hour time format, 20:36:00, November 15, 2019. Do note, you must use the name of the month, not the number of the month. You cannot say 11/15/2019. It must be January, February, March, April, May, June, July, August, September, whatever the friggin', all the way up to December. And then the year, okay? And there you'll see the time set by console. As the network grows, it becomes difficult to ensure all the infrastructure devices are operating with synchronized time using the manual method. Better solution is to configure the network time protocol on the network. Protocol allows routers on the network to synchronize their time settings with an NTP server. Provides more consistent time settings. NTP can be set up to synchronize to a private master clock. That can be an atomic clock, any device configured as a master, or GPS, okay? Or it can synchronize to a publicly available NTP server on the internet. NTP uses UDP port 123, documented in RFC 1305. Do note, NIST.gov, which consists of NIST, NIST.gov, NIST.gov-A, NIST-A.gov, NIST-B.gov, C, D, E, all the way up to whatever, okay? All of those different NIST-whatever.govs trace back to NIST.gov. So all you need to enter is NIST.gov as your time source. NTP networks use a hierarchical system of time sources. Each level in the hierarchical system is called a stratum. The stratum level is defined as the number of hop counts from the authoritative time source. That means your actual hard time source. Synchronized time is distributed across the network using NTP. The max hop count is 15. So you have stratum 0 through 15. Stratum 16, the lowest stratum level, indicates the device is unsynchronized. Okay? So at stratum 16, you're not synchronized with the rest of the NTP network. Okay? Now, when you see the clock there in the diagram, you see the clock at the top. That's stratum 0. That is the authoritative time source right there. And then stratum 1 gets its time from stratum 0. Stratum 2 gets its time from stratum 1. Stratum 3 gets its time from stratum 2. And you can see via the diagram that you will synchronize from authoritative time source to another stratum. And then from that stratum to another stratum, which may synchronize within the stratum. The synchronization within a stratum is to provide a sanity check in case somebody goes far off the actual time. You have a sanity check within the stratum. Stratum 0. These authoritative time sources are high precision timekeeping devices, assumed to be accurate with little or no delay associated with them. Stratum 1 devices are directly connected to the authoritative time source. They act as the primary network time standard. Stratum 2 and lower. Stratum 2 servers connected to Stratum 1 devices through network connections. Stratum 2 devices, such as NTP clients, synchronize their time by using the NTP packets from Stratum 1 servers. They could also act as the server for Stratum 3 devices. Time servers on the same stratum level can be configured to act as a peer with other time servers on the same stratum level for backup or verification of time. NTP likes a sanity check. So it's typical when you get to stratum 2 and higher numerically, lower in the time scheme, that you synchronize within the stratum for a sanity check. Before NTP is configured on the network, the show clock command displays the current time on the software clock. With the detail option, notice the time source is user configuration. That means time was manually configured using the clock command, clock set. The NTP server IP address command is issued in global config mode to configure 209.165.200.225 as the NTP server for R1. To verify the time source is set to NTP, use the show clock detail command. Notice now, since you set NTP server, the time source is NTP, okay? So initially, show clock detail on R1 tells you the time source is user config. That means somebody went in and typed clock set, whatever the value was for the clock, and then somebody came in and typed NTP server 209.165.200.225. And then the time source becomes NTP at that point because you're registering time via another device. Show NTP associations and show NTP status commands used to verify that R1 synchronized with the NTP server at 209.165.200.225. Notice R1 is synchronized with the Stratum 1 NTP server at 209.165.200.225, synchronized with the GPS clock, global positioning satellite. The show NTP status command displays R1 is now a Stratum 2 device, synchronized with the NTP server at 209.165.220.225. So you see there, show NTP associations. The address with the asterisk tilde, that is your time source. The reference clock is GPS in this case, Stratum 1. And then you have additional values for how often it's polled, when the last update came in, what the offset is between stratums. Listen, NTP can get very complex, or it can be very simple. You can even configure authentication on NTP. So on R1, show NTP status now. Clock is synchronized. Stratum 2, references 200.225. Nominal frequency, 250 hertz. The actual frequency is 249. Precision. This is precision. How close you are to the actual time. Okay? And it's 2 to the 19th freaking power, precise. Clock on S1, configured to synchronize to R1 with the NTP server command. The configuration is verified using show NTP associations. Output from this show NTP associations command verifies the clock on S1 is now synchronized with R1 at 192.168.1.1 via NTP. R1 is a stratum 2 device, making S1 a stratum 3 device that can provide NTP services to other devices in the network at stratum 3, stratum 4. Get it? So there you see NTP server on switch 1. You're telling it that it is R1. Show NTP associations. The address is 1.1. The reference clock is the original stratum 0 authoritative time source clock, which is the 200.225 at stratum 2. It's considered stratum 2 because you're getting it from stratum 1. Does that make sense? 1.1 is your time source for switch 1. 200.225 is the time source for stratum 1. And there's your polling, and there you see all the various settings. There's a lot more info that was omitted. Show NTP status. Clock is synchronized. You're at stratum 3 on switch 1. Okay, stratum 2 synchronized to stratum 1, which is acting as the authoritative time source, is 1.1. You got a packet tracer here. This one I'll give you a half hour on because, you know, it's NTP. It's a little different. Knock this out, please. NTP is a critical for you to understand on this test. Work the NTP packet tracer. It's not too difficult to do. Really shouldn't take you a half hour, but it might. Okay? I'm here if you need me. Give me a holler.